All right, y'all, welcome back. Today we are going to talk about section 2.4. It's on page 84 and 85 of your workbook, and we are going to talk about complex numbers. Okay, so this is going to look familiar to what you've done before. We're just going to add in a wrinkle. All right, so over here on the side, I have a couple examples we're going to start with, which you probably already know how to do these, but there's going to be one that's going to be brand new. All right, so if you wanted to figure out what the square root of 16 was, all right, most of you can probably do that in your head, but if you put that in a calculator, the square root of 16 is plus or minus 4. The reason why we have to put that plus or minus is because positive 4 times positive 4 is 16, and so is negative 4 times negative 4. That's also 16. So it could be either one of those, right? We're not really sure which one it is. The same thing applies to 25. That would be plus or minus 5 because positive 5 and positive 5 make 25, and so do negative 5 and negative 5. All right. Positive 18 is a little bit different. It's not a perfect square, but I could split it up into something that is a perfect square times something that isn't a perfect square. So for example, 18, that is the same as 9 times 2. And once you split it up, then take the square root of the one you know and keep the other one on the inside. So the square root of 9 is 3. And then 2 isn't a perfect square, and I can't split it up, so I just keep it the same. Okay, so 3 radical 2 or 3 square root of 2, same thing. All right, might hear me say radical, might hear me say square root. It's the same thing. All right. This last one is a little bit different. Now you'll notice that the only thing that's changed between the last one and the first one is this one has a negative sign. In your whole life, every math class you've ever been in, when you got the square root of a negative number, whenever you started square roots, I don't know what grade you do that in, but whenever you square rooted a negative number, that answer was automatically no solution. Like you just couldn't do it, okay, up until today. So today we're going to learn how you actually solve this. So the square root of 16, just the number itself, we already know is 4, right? We already know that the square root of 16 is 4. But since that negative is inside the radical, is underneath the radical, that means we have to put an I in there. So the answer to this problem is plus or minus 4I. Okay, it will always be plus or minus 4I. Okay, and so what that means is whenever you square root a negative number, there must be an I in your answer. So if there is a negative sign underneath the radical or underneath the square root, your answer has to have an I. That's the only difference between these two, right? That's the only difference between the first one and the last one. This one doesn't have a negative. This one does have a negative. And notice the answer, the only difference is this one has an I, this one doesn't. Okay? So we're going to do a couple of examples here. Sounds kind of confusing. All right, I get it. But once you see a few, I think it'll kind of make sense. All right, so we're going to do this first one. It says use square roots to solve each equation. Write using I. So we want to get x by itself. Okay, that's our goal, is to get the x alone. So we have to do the opposite. We have to get rid of this square. So we need to do the opposite of square. The opposite of a square is to square root both sides. And if we square rooted the left side, the square root and the square would cancel, leaving us with just x. So I have x equals, and on the right side, I have the square root of negative 5. Now, 5 isn't a perfect square, right? I can't split it up like into these like just 4 and 5. And I also can't break 5 down into like I did this one 9 times 2, because the only thing that multiplies to get 5 is 5 and 1. So negative 5 is the same thing as negative 1 times 5, right? That's the exact same thing. The only thing I can do is take that negative sign out. I'm still square rooting a negative number, right? So that means I have to put an I in front of the final answer. There's always a plus or minus. Whenever you square root something, you have to do plus or minus. And then since there's a negative underneath, I have to put an I. And the 5 just stays where it was because there's nothing I can do with the 5. Right? I can't split it up. It's only 1 times 5. There's nothing I can do. Okay? We're going to do the same thing with example B. So we're going to square root first to get rid of the square. Cancel, cancel. Leaves us with x equals the square root of negative 72. And you're looking at that and you're like, is that a perfect square? Like if you think of all your perfect squares, 4, 9, 16, 25, 36, 49, 64, 81. 72 is not one of those, okay? So I need to try to split up 72 into something that is a perfect square, which in this case, 72 would split into what? Think about it for a second. I will help you all out. 72 is the same thing as negative 16 times 4. Okay? Actually, I just lied to you. 72 is not 16 times 4. I put the wrong thing on there. Wah. Sorry. Negative 36 times 2 is what I meant to say the first time. Just ignore that 16 and 4. That's what happens when you're making videos at home. So negative 36 times 2. And then if you've done it right, you should know the square root of one of these. The square root of negative 36, the square root of 36 is 6. But since it's negative, I have to put 6i. Okay? And then the 2 just stays where it was. So the same thing would happen, like if I did this problem, but it was the square root of positive 72, I would do the exact same steps. 36 times 2, and the square root of 36 would just be 6. So notice the only difference between these two answers, right, is this one has an I, this one doesn't. It still has the plus or minus, it still has the 6, it still has the square root of 2, but since that's negative, I have to put I in front, okay? That's the only thing that changes when you're doing negatives under a square root, all right? Okay, the next thing we're going to talk about is how you add and subtract these, all right? So think of I just like any other variable, all right? Think of I just like any variable. So all we have to do is just combine like terms. Combine like terms. Which I know all of you can do. Okay, all we have to do is combine the like terms, and once we do that, we'll be finished, right? So it's just like adding 3x plus 5x will give you 8x. Same thing's going to happen right here. So if we look for some like terms, right, I have negative 4 plus negative 2. Negative 4 plus negative 2 would give me negative 6. I also have 6i plus negative 9i. 6 plus negative 9 would give me negative 3i, and we're done. Right, so all you are doing when you add or subtract is just combining like terms. Okay, nothing really changes. All right. Now subtraction is a little bit harder just because you have to be careful with the sign. So what I like to do personally is I like to rewrite the problem but change the minus to a plus. So the first one's never going to change. I'm going to change that minus to a plus sign. And then remember, everything after it has to change. So negative 4 would become positive 4. Plus I would become minus I. Right? So remember, change the negative to positive and then change everything after it. And now it's just like the first problem. Just combine the like terms. 3 plus 4 is 7. And then negative 2i plus negative 1i. Remember, there's a 1 in front still. Negative 2 plus negative 1 is negative 3i. And we're all done. Okay? So that is exactly what we needed. Any other questions? I don't know why I asked those questions. It's just my habit of being in class. That was silly. Okay, we're going to look at now what you do when you multiply them. All right, so this is where it gets a little bit harder is when you multiply them. All right, so when you multiply, okay, the thing that you have to remember, all right, always, is whenever you have I squared, that always equals negative 1. So if you ever get to a problem where there is an I squared, you are going to make that negative 1. okay, every single time. All right. So we're going to multiply the same way we've always multiplied. All right. So like if we took this first problem, we're going to distribute. Again, just like you've done 100 times, right? Just distribute it. I know there's fractions and that freaks some of you out, so just bear with me for a second. If you distributed 2/5 I times 10 in your calculator, if you type in 2/5 times 10, you would get 20 over 5, which is 4. So you would get 4I. If you did 2/5 I times negative 5/2 I, so 2/5 times 5/2 would give you negative I squared, because I times I is I squared, and 2/5 times 5/2 is just 1. So there's always a 1 in front of this. Okay? So we just distributed. Same thing we've done over and over. And if you don't like fractions, just let your calculator help you out. So the last thing that we have to do, and we have to remember, if you look, we have an I squared right here. Right? We have an I squared. An I squared is negative 1. So I'm going to take that I squared out, and in its place, I am going to put negative 1, because I squared will always, 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 always be negative 1. So then my final answer, these two negatives become a positive, is 4I plus 1. And I'm done. Okay, so as long as you remember that I squared is negative 1, you will be in good shape. Okay, it's always, always, always negative 1. Okay, all right, let's do B here. Again, we're going to distribute or FOIL. All right, so distribute 1/2 times 1/2. That's 1/4. 1/2 times negative 2I. 1/2 times 2 is 1. And then there's an I, so minus I. Now we're going to do the middle. 2I times 1/2 would be plus I. And then positive 2I times negative 2I would be negative 4I squared. Right? Just multiply like we did it every other time. Okay? Nothing really changes. Once we multiply, then we can simplify. So these two in the middle are the same, right? There's a negative I and a positive I. So those two are going to cancel out. They go bye-bye. This thing, I squared, remember, I squared is always negative 1. So we're going to change that. So the 1/4 isn't going to change. The negative 4 isn't going to change, but I squared is going to become negative 1. And now we just simplify. So the 1/4 still hasn't changed. Negative 4 times negative 1 is positive 4. And then we just add those up. So there's a bunch of different ways you could write this. 1/4 is the same as 0.25, so 4.25. You could say 4 and 1/4. You could say 17 over 4. All of these answers are acceptable. Right? You can make it a decimal. You could keep it as a mixed number. You can make it an improper fraction. Right? They all work. They all give you the same things. All right? So when you multiply, just do the exact same steps that you've always done when you multiply. Just remember that I squared is always negative 1. Okay? So just think of I like any other letter, just it adds this one extra step in there. All right? Okay, the last thing we are going to talk about is how you factor a sum of squares. So if you see this problem right here, okay, we have to factor this. Now, we learned a while ago about difference of squares, right? When you had something that looked like this, and it'd be like x squared minus y squared, right? And there was a square with a minus in the middle. And we called that difference of two squares. Okay, that was a few sections ago. This one is not difference of squares because it has a plus sign, but I could make it difference of squares. So I want to make this one look like that one, okay? So we're going to do opposite. We're going to do the opposite of what we did on that subtraction problem a minute ago. So, for example, I could change this plus sign to a minus, and if I changed it to a minus, that would make the positive 25 become negative 25. These two are exactly the same because a negative and a negative make a positive, right? So I just rewrote it in a different manner, okay? And now this problem looks exactly like what we had before, right? And if you remember when we split this up, it would be x plus y, x minus y, right? So we square root each of them, which is exactly what we're going to do right here, okay? So if I were to split this one up, now that they're the same, this is a square, this is a perfect square, so now I can split it up. The square root of 4x squared. The square root of 4 is 2, so there's going to be a 2 first in each of them. The square root of x squared is just x, 2x and 2x. And then the square root of negative 25. Most of you know that the square root of 25 is 5, right? But it's negative. So since it's negative, we have to put our I in there. So 5i and 5i. One of them is always plus, one of them is always minus. And we're finished. Okay, so we can change a sum into a difference by making it minus and changing whatever comes after it. Okay? All right, today your assignment, you all have a complex number puzzle that you are going to complete. So it's like a tangram where you're going to solve some problems and then you're going to meet up the answers and the problems together so it will form a box. Okay, it's on Google Slides. You will see it on our Canvas page. If you have questions, please let me know. I will be more than happy to help you. Okay, thank you.